When assembling electrical Seal-Tite whips, understanding the requirements for listed components is crucial. You are correct that you can assemble your own Seal-Tite whip, provided that all individual components used in the assembly are independently listed. This means the flexible metal conduit, also known as Seal-Tite, the connectors, and the conductors must each carry a listing mark from a recognized testing laboratory such as UL or ETL. The concept revolves around the fact that the National Electrical Code, or NEC, generally requires electrical equipment and materials to be listed. Listing ensures that these items have been tested and found to be safe for their intended use. However, the NEC also allows for field assembly of certain electrical components, as long as each part meets the applicable standards. When assembling a Seal-Tite whip, you are essentially creating a piece of equipment in the field. As such, it doesn't need to be listed as a complete assembly, but each component must have its own listing. Let's break down each component. Firstly, the flexible metal conduit, or Seal-Tite, itself must be listed. This listing confirms that the conduit meets the necessary requirements for flexibility, crush resistance, and liquid tightness, as well as other relevant performance characteristics. The listing mark on the conduit indicates that it has been tested to the applicable UL standard, such as UL 360. Secondly, the connectors used to terminate the Seal-Tite to the junction box or equipment enclosure must also be listed. These connectors are designed to provide a secure and liquid-tight connection, and their listing ensures they meet the required mechanical and electrical specifications. Look for connectors that are specifically listed for use with flexible metal conduit. Thirdly, the conductors used inside this Seal-Tite must be listed as well. This means that the wire insulation, size, and ampacity must comply with the NEC requirements and the applicable UL standards. The conductors must be suitable for the voltage, current, and temperature conditions of the application. When selecting conductors, consider the type of insulation, such as THHN or THWN, and ensure it is appropriate for the environment. For example, THWN is suitable for wet locations, while THHN is typically used in dry locations. Now, let's consider some additional points related to Seal-Tite whip assemblies. One point is that the length of the Seal-Tite whip should be kept to a minimum to reduce voltage drop and impedance. Excessive length can also make it more difficult to pull conductors through the conduit. Another point is that the Seal-Tite whip should be properly supported to prevent strain on the connectors and conduit. The NEC specifies requirements for supporting flexible metal conduit, and these requirements should be followed. For example, the NEC may require supports every 18 inches for certain sizes of flexible metal conduit. A third point is that the Seal-Tite whip should be installed in a manner that prevents physical damage. Avoid routing the whip in areas where it could be easily crushed, cut, or otherwise damaged. If necessary, provide additional protection, such as a guard or sleeve. When making connections to equipment, be sure to follow the manufacturer's instructions and the NEC requirements. Use the correct size and type of connector, and tighten it to the specified torque. Over-tightening or under-tightening can compromise the integrity of the connection. In addition to the listing requirements, there are also installation requirements in the NEC that must be followed when using Seal-Tite whips. For example, the NEC specifies the minimum bending radius for flexible metal conduit. This radius is intended to prevent damage to the conduit and conductors. The NEC also addresses the grounding and bonding requirements for Seal-Tite whips. The conduit itself is not typically considered an effective grounding path, so a separate grounding conductor must be installed inside the conduit. This grounding conductor should be sized according to the NEC tables and connected to the equipment grounding busbar in the panel board or enclosure. It's also important to ensure that the Seal-Tite whip is installed in a neat and workmanlike manner. This means that the conduit should be run in a straight and orderly fashion, and the connectors should be properly aligned. Avoid creating unnecessary bends or kinks in the conduit. Using Seal-Tite whips can offer several advantages in electrical installations. They provide flexibility, which can be useful when connecting equipment that may need to be moved or adjusted. They also offer protection against moisture and physical damage. However, It's important to follow the listing and installation requirements to ensure a safe and reliable installation. When in doubt, consult with a qualified electrician or electrical inspector to ensure that your Seal-Tite whip assembly meets all applicable codes and standards. Improperly assembled or installed Seal-Tite whips can pose a safety hazard and may not comply with the NEC. Remember, the key is that each component must be listed individually, even if the complete whip assembly is not listed as a unit. This approach allows for flexibility in the field while still maintaining a high level of safety and code compliance. Furthermore, always refer to the latest edition of the NEC and local codes for the most up-to-date requirements. Electrical codes can change over time, so it's important to stay informed. In summary, to correctly assemble Seal-Tite whips, remember firstly, all components including the Seal-Tite conduit, connectors, and conductors must be listed by a recognized testing laboratory. Secondly, follow all applicable NEC and local code requirements for installation, grounding, and bonding. Thirdly, ensure the whip is properly supported and protected from physical damage. And fourthly, consult with a qualified electrician or electrical inspector when in doubt. By adhering to these guidelines, you can create safe and compliant Seal-Tite whip assemblers for a variety of electrical applications. The importance of using listed components cannot be overstated. Listing provides assurance that the product has undergone rigorous testing to meet specific safety and performance standards. This testing typically includes evaluations for electrical, mechanical, and fire-related hazards. When you use listed components, you are reducing the risk of electrical shock, fire, and other potential hazards. Moreover, using listed components can help to ensure that your electrical installation complies with the NEC and other applicable codes. Code compliance is essential for safety and can also help to avoid costly fines and delays. In addition to listing, it's also important to select components that are suitable for the specific application. For example, if the Seal-Tite whip is being installed in a wet location, you will need to use connectors and conductors that are specifically listed for wet locations. Likewise, if the whip is being installed in a hazardous location, you will need to use components that are listed for use in that type of environment. When selecting components, consider the voltage, current, and temperature requirements of the application. Be sure to choose conductors that are properly sized for the load, and use connectors that are rated for the voltage and current levels involved. Also, consider the ambient temperature and any potential heat sources that could affect the performance of the component. Proper selection and installation of Seal-Tite whips are essential for ensuring the safety and reliability of electrical systems. By following the guidelines outlined above and consulting with qualified professionals when needed, you can create electrical installations that meet the highest standards of safety and code compliance. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Ignoring the importance of proper grounding and bonding can have severe consequences. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. Bonding connects all metal parts of the electrical system together, which helps to equalize voltage potentials and reduce the risk of shock. The NEC has specific requirements for grounding and bonding, and these requirements must be followed carefully. The size of the grounding conductor is determined by the size of the circuit conductors. The grounding conductor must be connected to the equipment grounding busbar in a panel board or enclosure. All metal parts of the electrical system, including conduit, enclosures, and equipment, must be bonded together. Bonding can be achieved by using bonding jumpers or by using listed connectors that are designed to provide a reliable electrical connection. Improper grounding and bonding can create a dangerous situation that could result in electrical shock or fire. It's important to take the time to properly ground and bond all electrical equipment and systems. Finally, consider the environmental factors that may affect the performance of the Seal-Tite whip. For example, if the whip is being installed in a corrosive environment, you will need to use components that are resistant to corrosion. If the whip is being installed in a high vibration environment, you will need to use connectors that are designed to withstand vibration. If the whip is being installed in an area where it will be exposed to sunlight, you will need to use conduit and conductors that are UV resistant.